In this video today, we are going to be talking about how to balance chemical equations. Now, the number one thing that you need to keep at the forefront of your mind here with balancing chemical equations is the law of conservation of mass, which says that matter cannot be created or destroyed. So when we think about that in the context of chemical reactions, we have some starting materials, some amount of starting materials, and we must finish with those same materials. Now we can rearrange the atoms, right? We can, split up some bonds and form some new bonds, but we can't get rid of anything that we started with, and we can't create atoms out of thin air. So this is the guiding principle for balancing chemical equations, or the reason that we need to balance equations is so that we can show that the law of conservation of mass stays in effect. So we balance equations to prove that, hey, we still have the same stuff that we started with, the same amounts of what we started with at the end of an equation. So that's just restating it. We must have the same number of atoms before and after a reaction takes place. And so we'll do that by using coefficients to show the number of each substance. And that's so that we can keep track of the atoms. So if we start with 2 hydrogens, we need to end with 2 hydrogens. And that's what a coefficient is. It's going to be that number in the front that tells us, hey, you have this many of whatever atom it is. The coefficients change the number of each reactant, but they don't change the formula for the substance. So if we had a formula of HCl and we put a 2 coefficient in front of it, all that tells me is that I have 2 hydrochloric acid molecules. It doesn't say that I have H2Cl2. That's not the case. What it's saying is I have 2 of this whole thing here. It's like in math when you have a coefficient in front of parentheses. Right? So when you have a number in the front, it's saying, hey, I have 2 of these whole things here. That's what a coefficient does. It does not change the formula for the substance. It just changes the number of each reactant or product. Oh, and just that last part here is that the lowest ratio of whole numbers will always be used. So if all of your coefficients are divisible by 2, then you need to simplify those coefficients. Just when we wrote the formulas for certain ionic compounds, we had to simplify the subscripts of each metal or non-metal. Sometimes we have to simplify the coefficients as well. So let's see this in action. All of these equations are currently unbalanced. So our job is going to be to figure out, well, how do we deal with this? And this might jump out at you right away, but you might want to also take a little bit of time and break it down a little bit. So I'm going to show the broken down version first, and then maybe when you get good at it, then you can start jumping to more like a balance, which we'll discuss. So on the left-hand side here, I have mercury and I have oxygen. I can see that I have 1 of both of those things on the reactant side. On the product side, I have 1 mercury, but I have 2 oxygens. So I can see immediately that my oxygens are not currently balanced. So what I'll have to do is my goal is to get 2 oxygens on the left-hand side. So if I do that, I'm going to have to put a coefficient of 2 in front of HGO. The problem is when I do that, now that gives me 2 mercuries as well. So if I go back to the right-hand side, in order to balance out the 2 mercuries from the left, I'm going to need 2 mercuries on the right. And so I will add a 2 there in front of mercury. So it's sort of like a bouncing back and forth. You want to assess what you have on the left side, what you have on the right side, sort of figure out, hey, how do I get from point A to point B? Or how do I make this equal? Let's look at another example. This one's sort of backwards of the one that we just did. And so on the left-hand side, we have 1 magnesium and we have 2 oxygens. Whereas on the right-hand side, we have 1 magnesium, but only 1 oxygen. So I know I'm going to need to get to 2 oxygens in order to make the oxygens balanced on both sides, which means I'm going to have to put a 2 here in front of MgO, magnesium oxide. Once I put that 2 in front of MgO, now that tells me I have 2 magnesiums on the right-hand side, so I'm going to need 2 magnesiums on the left-hand side. And I do that by putting a 2 coefficient in front of magnesium. So that balances this equation here. Now, what happens if we have, 4 formulas? Now, in the first 2 equations, we only had 3 formulas that we were dealing with. So maybe this is going to get a little bit harder. We'll find out. On the left-hand side here, I have 1 hydrogen, I have 1 chlorine, and I have 2 oxygens. On the right-hand side, I have 2 hydrogens, I have 2 chlorines, and I have 1 oxygen. So as you can see, all 3 of these atoms need to be balanced. So I always recommend to start with oxygens and always try to balance your oxygens first, just because they usually end up in even numbers when you're dealing with O2. So that's kind of how I would attack this problem. But if you want to start at hydrogen and then work your way down, that's fine too. So like I said, if I start with oxygen, I know that I need to get 2 oxygens on this right-hand side here. And in order to get 2 oxygens, I have to put a 2 in front of H2O because that 2 is going to distribute to the O. But what that does is also distributes to the hydrogen, which means I now have 4 hydrogens on the right-hand side. So if I want 4 hydrogens on the right-hand side, I need to have 4 hydrogens on the left-hand side, which means I'm going to have to put a 4 in front of HCl. When I put a 4 in front of HCl, yeah, I have 4 hydrogens, but now I also have 4 chlorines. And in order to balance out my 4 chlorines, get this to 4, I'm going to have to put a 2 in front of Cl2. Right, 2 times Cl2, that'll give me 4 chlorines. Now, you might be thinking, hey, isn't this simplified now? Or can't I simplify this if I have a 4, a 2, and a 2? And the answer is no. You have to be super careful. As you can see, there's no coefficient written here in front of the oxygen, which means that these coefficients are already in their simplified form with the 4, 1, 2, and 2. So make sure you're paying attention to when you don't include a subscript. If it helps, you can feel free to write in a subscript of 1 for now. Right? Say like, hey, I have 1 of those things, but eventually we're going to just do away with those coefficients of 1 altogether. Just like in math, you wouldn't write 1x, you would just write x. So let's do 1 more here. I'm going to do number 4 at the top, and then I want to see if you guys can do 5 and 6 on your own. But like I said, I'm going to do 4, and I'm going to try to just bounce this time. Instead of showing all my work down there at the bottom, I'm just going to bounce back and forth, and I'll sort of talk about that here. So starting with the copper, right? I see that I have 1 copper on the left-hand side and 1 copper on the right-hand side, so those are balanced. So I'm just going to move on to the chlorine. Right, I see that I have 2 chlorines on the left, which means I'm going to need 2 chlorines on the right. But when I add that coefficient of 2, it also gives me 2 sodiums. So now I need to go back to the left-hand side and put a 2 in front of NaOH in order for the sodiums to balance out. When you do that, this is our double checking step. We put our 2, and now we've got 2 hydroxides, but look at that. I had 2 hydroxides on the right-hand side already. So now this is balanced and I'm done. So that's sort of how you balance. You start on one side, take it over to the, start on the left, take it to the right, and that passes you back to the left and back and forth until things are balanced. Like a ping pong match. So what I want you to do is pause the video and try to balance these next 2 equations. I'm going to put those up on here, so I'll hit you right back here in a second. All right, so if you come back here, you can see that in number 5, we're going to have a coefficient of 2 in front of iron chloride, and then no coefficient there in front of beryllium phosphate, but that's just an assumed 1, so if you wrote a 1, that's okay for now. And then if we move on to the reactant side, we have 3 beryllium chlorides and 2 iron 3 phosphates. So that was number 5. And in number 6, this one can kind of give people fits, and that's because the oxygen sort of throws people off. So my number 1 suggestion when you're dealing with a reaction that has all carbons, hydrogens, and oxygens is first balance the carbons, then balance the oxygens, and then the hydrogens usually end up working themselves up. So that's my tip there. But really, that was all there is to balancing. So I want you to go ahead and get that practice worksheet in, and let me know if you have any questions.